Unit 6, Day 4, Logarithmic Functions. Today you are going to write equivalent forms of exponential and logarithmic functions, and you are also going to write and evaluate logarithmic functions. A logarithm is the exponent to which a specified base is raised to obtain a given value. You can write an exponential equation as a logarithmic equation and vice versa. So looking at the equation below, if you have b to the x power is equal to a, you can rewrite that as log with a base b of a is equal to x. So looking at the colorful arrows, you can see where the variables translate. Your b needs to be greater than 0 and b cannot equal 1. In example 1, we are going to write each exponential equation in logarithmic form. So we're going to use the formula up here in the upper right-hand corner of the screen. So on example A, we have 3 to the 5th power is equal to 243. So we rewrite that as a logarithm and we say log with a base 3 of 243 is equal to 5. When we rewrite example B, we say log with a base 6 of 1 over 36 is equal to negative 2. Example C, we can rewrite 25 to the 1/2 power equals 5 by saying log with a base of 25 of 5 is equal to 1/2. And we can rewrite D, 8 to the 0 power equals 1 as log with a base 8 of 1 equals 0, which is just 1. Write each logarithmic equation in exponential form. So now we're going to go the other direction. So our base is going to be 2 raised to the 7th power is equal to 128. Example B, 4 raised to the negative 2nd power is equal to 1 over 16. C, 8 raised to the 1/3 power is equal to 2. And then D, 6 raised to the 1st power is equal to 6. Logarithms are the inverse of exponents. If we have f of x is equal to 10 to the x power, we can rewrite that as f to the negative 1 of x is equal to log with a base 10x. The properties of logarithms which you need to memorize, so you need to memorize that conversion formula and you also need to memorize these two properties. If we have log with a base b of b, so these two numbers right here match, it equals 1 whole. If we have log with a base b of 1, it will always equal 0. So it doesn't matter what this b is. If you have a 1 right here, it will equal 0. A logarithm with a base 10 is called a common logarithm. If no base is written for a logarithm, the base is assumed to be 10. So for example, if we have log of 5, we assume that this little base right here that's not written is a 10, and we say that is a common logarithm. So now we can evaluate some examples by using mental math. Example 3a says the log of 100,000. So we say 10, because this is a common log, that's missing a 10 right there, to what power equals 100,000? Well, our answer would be 5. If we say 5 to what power equals 125, so we want to know what this equals. You can see I was using that conversion formula. 5 to the 3rd power equals 125. Log with a base 5 of 125 equals what? Well, 5 to what power equals 1 over 25. We know it's going to need to be a negative in order to get a fraction. 5 times 5 is 25, so negative 2. Log with the base of 64 of 8 is equal to what? 64 to what power is equal to 8. So we're going from a larger number to a smaller number, so we're going to have a fraction as our exponent, so it equals 1/2. Log with a base of 10, because it's a common log, is equal to what? 10 to what power is equal to 0.01, which is the same thing as saying 10 to what power is equal to 1/100th. So we have a negative 2. Log with a base 4 of 64 is equal to what? 4 to what power is equal to 64? And 4 to the third power. You now can complete your worksheet.